somewhere behind your car's dashboard. Not the screen, not the speaker array, not the processor that runs the navigation. There is a chip about the size of a grain of rice that holds exactly one job. It stores the firmware. Your car reads the moment you turn the key. Before the instrument cluster lights up, before the backup camera sees anything, before the engine management system runs its first check, that chip has to answer. It is called NOR flash. One fab in China sent a letter to its distributors in late June saying every NOR flash product line it makes goes up 25%, effective the 6th of July. The chip remains invisible. The price is no longer. The question this map has to answer is whether any automaker, any Tier 1 supplier, any distributor sitting between that fab and a finished vehicle has a second road, or whether the entire supply web was built on the assumption that this particular junction would never move. A price increase is not a business event in isolation. It is a change in the topology of a supply web. When one node reprices, every line that runs through it either absorbs the shock, finds a detour, or hits a wall. This map traces which of those three outcomes waits at each junction between a fab in Shenzhen and a vehicle rolling off an assembly line. We follow a single NOR flash die from the fab gate through distributor inventory into a Tier 1 supplier's qualification lab and out into the three distinct vehicle modules that depend on it. The map fills in one segment at a time. One node is a true dead end with no exit yet confirmed. Giantec Semiconductor is not a name that appears in most supply chain briefings. It does not have the profile of the largest logic foundries, but the notification it sent to distributors traveled the same channels as any price move from a major supplier, and it carried the same weight because of what flows through this node. NOR flash is not dynamic random access memory. It is not the high-density storage in your phone. It is a read-mostly memory architecture. Slow to write, fast to read at any address, which is precisely what a microcontroller needs when it is pulling stored firmware at boot. Automotive designs rely on it because it is non-volatile, meaning it holds data with no power applied, and because its read latency is deterministic. The vehicle's safety systems need to know exactly how long it will take to read the firmware. NOR flash gives them that guarantee. The fab that produces it is not running the most advanced process nodes in the industry. It is running mature process geometries that require less exotic tooling than the leading edge of logic. That distinction matters enormously when the bypass question comes up later. But the pricing authority at this node does not come from process sophistication. It comes from concentration. Reports across semiconductor trade publications suggest a small number of Chinese fabs now account for a meaningful share of NOR flash supply reaching automotive distributors globally. No single public benchmark confirms exact percentages, and independent market share figures vary enough that citing a number here would be false precision. What the distributor notifications confirm is the commercial reality. When Giantec moves the price, the line moves. Think of it as a junction box in a building's electrical panel. Not the generator, not the transformer at the street, just the box where every circuit in one wing terminates. The box is not glamorous, but if the company that controls it changes the rate on every connection running through it, every tenant in that wing feels it, whether they know the box exists or not. Node reached. Giantec fab gate. Status. Choke point. With no bypass currently in place, the price has moved. The line that runs through this node carries no alternate routing at commercial volume, and the increase is already traveling downstream. The line leaving the fab gate does not arrive directly at a car. It arrives at a distributor, a company that buys NOR flash in volume, warehouses the inventory, and resells under contracts that often include price lock provisions for a defined window. That is where the first friction surfaces. A distributor holding bonded inventory purchased under a price-locked agreement now sits between two contradictory realities: the contract it signed weeks or months ago, and the new price the fab is asserting from July 6th. The legal exposure is not hypothetical. Price lock disputes in semiconductor distribution are documented and litigated. They emerged in force during the 2020 to 2022 shortage cycle and again in various commodity repricing events since. The specific texture of the Giantec situation, as reported in trade channels, is that the July 6th effective date gave distributors little runway to absorb, negotiate, or pass the increase through before it landed on open orders. A distributor holding undelivered inventory under a price-locked agreement has four choices: pass the increase to the Tier 1, absorb the margin hit itself, dispute the price change contractually, or some combination of all three. Each of those choices draws a different line on the map, and they do not lead to the same place. What they share is this: the distributor cannot manufacture an alternate source. It can only move the cost or argue about who holds it. My read is that the locked price contract dispute is the most underreported stress point on this map. Analysts cover fab capacity and original equipment manufacturer design wins. Nobody is watching the legal exposure sitting in bonded warehouses right now. That gap in coverage is itself a signal about where the next friction in this web surfaces. A distributor with a price-locked contract is like a freight broker who guaranteed a shipper a fixed rate for a lane, then discovered the one toll road the route crosses tripled its fee after the contract was signed. The broker can eat the difference, fight the toll authority, or tell the shipper the rate changed. There is no fourth option that makes the toll disappear. Node reached. Distributor inventory node. Status: choke point with no bypass being built. The distributor has no mechanism to source around the fab, only to negotiate who absorbs the cost, and that negotiation is underway with no resolution confirmed in public reporting. Follow the line past the distributor to the automotive Tier 1 supplier, the company that takes the NOR flash die and integrates it into a module, an instrument cluster board, an advanced driver assistance compute board, a telematics unit. Here the map reveals its most structurally important constraint, and it is not financial, it is temporal. Automotive components that touch safety-adjacent functions require qualification under standards that specify environmental stress testing, failure mode analysis, and a traceable supply chain. A boot memory chip that stores the firmware a safety system reads at startup is safety-adjacent. The qualification process from initial sample submission to production release typically runs between 9 and 18 months for a new or alternate source. That range is consistent with the requirements under the semiconductor qualification standard the automotive industry applies and the quality management standard governing the supply chain itself. The Tier 1 cannot simply switch to a different NOR flash vendor because the price moved. It has to re-enter a process that, by design, does not move quickly. I want to push back on the instinct to frame a one-year requalification window as a bureaucratic failure. It is not. It is the correct answer to the question: how long does it take to prove a safety-adjacent memory part will not corrupt firmware under thermal stress cycling, vibration, humidity, and voltage extremes? The timeline is the standard. The failure was designing a supply chain with a single approved source and assuming the standard would never have to be invoked. The qualification is like a bridge certification. When an inspector certifies a bridge safe for heavy truck traffic, that certification is valid for one specific bridge design. If the city wants to route trucks over a different bridge, even one that looks nearly identical in every visible dimension, the inspector starts the certification from scratch. You cannot transfer the approval. The Tier 1's qualification is that certification. A new source is a new bridge, and the inspector's calendar does not care that the old bridge just raised its toll. Reports from automotive supply chain coverage suggest single-source dependency on specific memory components is common across Tier 1s, though exact prevalence figures are not independently benchmarked across the industry at a level that would let anyone cite a confident number. Node reached. Tier 1 requalification node. Status: choke point. With a bypass under construction, some Tier 1s, reports suggest, have initiated alternate source qualification processes following the Giantec notification, but none have confirmed a second source at production volume with a timeline shorter than the qualification standard requires, which means the bypass is real, but the road is not yet open. From the Tier 1, the line does not stay single. It splits. A modern vehicle does not carry one NOR flash chip. It carries several, distributed across modules that were often designed and sourced independently. The digital instrument cluster reads its display firmware from NOR flash at boot. That is the die we have been following since the fab gate. The Advanced Driver Assistance Domain Controller, depending on the vehicle's electrical architecture, may use NOR flash for configuration data or safety-critical parameter storage. The telematics unit, which manages cellular connectivity and over-the-air update delivery, typically stores its base firmware in NOR flash as well. These modules frequently come from different Tier 1s, qualified at different times, potentially sourced from different vendors on paper. But reports suggest a meaningful share of the supply for these specific automotive applications routes through the same small set of Chinese fabs, because those fabs expanded capacity and competed on price during the period when the automotive industry was restructuring its semiconductor sourcing after the shortage years. The result is a map that appears diversified at the module level. Different suppliers, different boards, different qualification histories, but converges back toward the same node when you trace each line to its source. Picture a city where three independent neighborhoods each maintain their own road network. The hospital district, the commercial district, the residential district all have local streets that look separate on a neighborhood map. Zoom out, and every one of those local networks funnels onto a single causeway to cross the river. The causeway installs a new toll. All three neighborhoods pay it, whether they knew they shared a crossing or not. The cost exposure in this vehicle is not sitting in one module. It is the aggregate of every module whose line traces back through the same fab gate, each carrying its own share of the 25%. Node reached. Vehicle Module Exposure Node. Status: junction. China has already routed through. The concentration of NOR flash supply through Chinese fabs is an established condition, not a new development. And the 25% increase is the first moment that condition became commercially legible to the original equipment manufacturers sitting at the far end of the line. Now, hold the map at its hardest point. The node with no exit yet confirmed is the automaker whose bill of materials lists a single NOR flash vendor for a given module where alternate source qualification has not been initiated, is not in progress, or is in early stages with no timeline to production release. The requalification clock is real and runs in one direction. An original equipment manufacturer that has not started a second source approval process cannot compress 12 months of stress testing because a price letter arrived. The qualification standard is not a negotiating position. Every month, the automaker spends absorbing the increased cost while waiting for an alternate source to clear qualification is a month the incumbent supplier holds pricing authority with no competitive check. If concentration of NOR flash capacity at mature process nodes remains in the same geographic and corporate footprint, and there is no confirmed large-scale investment in equivalent capacity outside that footprint at volumes automotive requires, The choke point does not dissolve on its own. It may become permanent for a given platform's lifetime, which in automotive runs years, not months. The strongest argument that this dead end has an exit is the one the industry proved it could find after 2022. When original equipment manufacturers perceived existential supply risk in a semiconductor category, some of them began direct fab engagement, strategic inventory programs, and multi-source qualification initiatives at a pace that would have seemed impossible before the shortage. Reports suggest some manufacturers and Tier 1s have initiated or accelerated alternate NOR flash source qualifications following the Giantec notification. If that is happening at scale, the bypass is being built. Not yet open, but under construction. There is also a structural argument worth holding alongside that one. NOR flash at mature process nodes is not architecturally exotic. The process technology required to produce it is accessible to a wider range of fabs than, say, extreme ultraviolet lithography-based logic at the leading edge. That means the pool of potential alternate sources is real. The qualification timeline is the binding constraint, not the process barrier. The dead end is genuine for any automaker whose qualification clock has not yet started. The bypass, where it exists, is a road being paved while traffic is still moving on the only bridge. The automaker with no second source approved is not merely exposed to this price increase. It is exposed to every repricing decision that node makes until the alternate route is certified and open. Step back and read the whole map. The choke points that have partial bypasses are being routed around, slowly. Distributors have negotiated partial cost absorption and pass-through agreements in some cases. The cost moves, but the line does not break. Some original equipment manufacturers learned from the shortage years to map their module-level sourcing at least one layer deeper, and some have multi-source programs now underway. Those are real detours. The choke points that remain are the fab gates pricing authority, which no alternate source at confirmed production volume has displaced, the requalification timeline, which the standard will not compress, and the single-source bill of materials entries at original equipment manufacturers who have not yet initiated a parallel qualification. That last one is not publicly disclosed. You will not find it in an earnings call or a press release, but the structure is sound, and the dead-end case follows from it. My honest call is this. The automotive industry treated NOR flash as a commodity fastener, interchangeable, abundant, cheap enough that strategic attention was better spent elsewhere. This map suggests it was something else entirely. A wire that ran through a single node, dressed to look like background infrastructure because it had never failed visibly before. The 25% increase is recoverable. Companies will negotiate, absorb, or pass through the cost, and the vehicles will still roll. The structural condition that made the 25% possible, a single approved source in a geography with pricing authority and no near-term commercial alternative, does not change with one qualification cycle. That condition is what the map has been drawing this whole time. That single NOR flash die, the one sitting behind your dashboard waiting for the ignition signal, has been the fixed point at the center of every segment of this map. Not because it is the most sophisticated component in the vehicle, not because it handles the most data or runs the most complex computation, because it is the one almost nobody was watching, which is exactly how a wire that carries real load gets mistaken for something incidental. The map is complete. The choke points that have bypasses are being routed around, one qualification cycle at a time. The ones that do not are still there, carrying the same load on the same single road, and now the road has a new toll. The question I want to leave on the map: which automotive NOR flash program gets its alternate source qualification across the line first? And when that happens, Does the pricing authority of the fab that moved first actually weaken? Or does concentration in the mature node supply base hold regardless of how many qualifications clear? That answer is not settled yet. Drop your read in the comments. If supply web tracing at this level is useful to you, subscribe and turn on notifications. The next map starts somewhere the thumbnail will not make obvious until the final segment reveals which node it was drawing toward the whole time.